Hi, I'm Gabe. For this problem, we're asked to solve the equation the absolute value of x plus 1 is equal to x squared minus 5. Now, since our equation involves an absolute value, we need to rewrite this as two separate equations. We need to think about this as the equation x plus 1 equals x squared minus 5 and negative x plus 1 is equal to x squared minus 5. We'll begin by solving x plus 1 equals x squared minus 5. In order to solve this equation, since it's a quadratic, let's subtract x plus 1 from both sides of the equation, and we'll obtain x squared minus x minus 6 equals 0. Now this is a quadratic that factors into x minus 3 times x plus 2. Now since we have two factors and their product is equal to 0, we can set each equal to 0 and solve. So setting x minus 3 equal to 0 and x plus 2 equal to 0, we can add 3 to both sides of this equation, obtaining a potential solution of x equals 3. And we could subtract 2 from each side of this equation, obtaining a potential solution of x equals negative 2. Now solving negative the quantity x plus 1 equals x squared minus 5, let's first distribute the negative sign. So we have negative x minus 1 equals x squared minus 5. And again, since it's a quadratic, we'll want to set this equal to 0 and solve. So let's add x and 1 to both sides of the equation, and we obtain x squared plus x minus 4 equals 0. Now since this does not factor, we'll use the quadratic formula to find the two solutions to this equation. So x is equal to negative 1, since our b term is 1, plus or minus the square root of 1, again, our b term is 1, so 1 squared is 1, minus 4 times a, which is 1, times our c term, which is negative 4, and this is all divided by 2 times a, which is just 1. So we're dividing by 2. So we find our other two solutions are x is equal to negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 4, or 1 plus 16, which is 17, all divided by 2. So now we have four potential solutions. We have to check and make sure that these satisfy our initial equation. Now to check our solution, we substitute each of these values back into the original equation. Substituting x equals 3 back into the original equation and simplifying, we find that we end up with 4 equals 4, which is a true statement. So x equals 3 is a solution. Substituting x equals negative 2 back into the original equation and simplifying, we find that we end up with 1 equals negative 1, which is not a true statement. So x equals negative 2 is not a solution. Substituting x equals negative 1 plus the square root of 17 divided by 2 back into the original equation and simplifying, well, what we find is that we have 1 plus the square root of 17 divided by 2 is equal to negative 1 plus the square root of 17 divided by 2, which again is not a true statement. So 1 plus the square root of 17 divided by 2 is not a solution to the equation. And finally, we have x equals negative 1 minus the square root of 17 divided by 2. When we substitute this back into the original equation, what we find is we have negative 1 plus the square root of 17 divided by 2 is equal to negative 1 plus the square root of 17 divided by 2. This is a true statement. So x equals negative 1 minus the square root of 17 divided by 2 is also a solution. So the two solutions to our equation are x equals 3 and x equals negative 1 minus the square root of 17 divided by 2. Thank you.